Study Session 6. Experimental Control. Introduction. This study session discusses the nature of experimental control, which includes the independent variables control and extraneous variable control. Furthermore, the study session explains kinds of control of independent variable, extraneous variable, and techniques of control. At the end of this session, you should be able to 1. Describe the nature of experimental controls. 2. Control the independent variables. 3. Control extraneous variable in research. The nature of experimental control. Among the most striking advances in methodology was the recognition of the necessity for a normal control conditions against which to evaluate experimental treatments. The problem of controlling a variable, a critical phase in the planning and conduct of experiments, requires particular vigilance. To start, the word control implies that the experimenter has a certain power over the conditions of an experiment. That power is to manipulate variables systematically in an effort to arrive at a sound empirical conclusion. Let us illustrate by using this sophisticated but still ancient investigation about a control condition. Athenaeus, in his Feasting Philosophers, describes how it was discovered that citron was an antidote for poison. It seems that a magistrate in Egypt had sentenced a group of convicted criminals to be executed by exposing them to poisonous snakes in the theater. It was reported back to him that though the sentence had been daily carried out and all the criminals were beaten by the poisonous snakes, none of them had died. The magistrate at once commenced an inquiry. He learned that when the criminals were being conducted into the theater, a market woman, out of pity, had given them citron to eat. The next day, on the hypothesis that it was the citron that had saved them, the magistrate had the group divided into pairs and ordered citron fed to one of a pair but not to the other. When the two were exposed to the snakes a second time, the one that had eaten the citron suffered no harm, while the other died instantly. The experiment was repeated many times, and in the same way, says Athenaeus, the efficacy of citron as an antidote to poison was firmly established. Jones, 1964. In such ways, the logic of experimental control developed, slowly leading to our present level of methodological sophistication. The problem of controlling variables, a critical phase in the planning and conduct of experiments, requires particular vigilance. To start, the word control implies that the experimenter has a certain power over the conditions of an experiment. That power is to manipulate variables systematically in an effort to arrive at a sound empirical conclusion. Let us illustrate the previous pharmacological example. Independent variable control. First, from the illustration given above, the magistrate exercised control over his independent variable by producing the events that he wished to study. Thus, the first sense of the word control is when the independent variable is varied in a known and specified manner. Here, the independent variable was the amount of citron administered, and it was purposively varied in two ways, 0 and some positive amounts. Extraneous variable control. The second sense of control was when the magistrate sought to determine whether variation of amount of citron administered to the poisoned men would affect their impending state of inanimation, that is, certainly a clear-cut dependent variable measure, if ever there was one. To find out whether these two variables were related, however, one should ask about other extraneous variables that also might have affected the man's degree of viability. If there were such, the relationship that the magistrate sought might have been hidden from him. Some substance in the men's breakfast, for instance, might have been an antidote, The men might have been members of a snake cult and thereby developed an immunity, and so forth. In the absence of knowledge of some extraneous variables, it was necessary to assume that they might have affected the dependent variable. Hence, their possible effects were controlled. The fact that only members of the group that received citron survived ruled out further consideration of the extraneous variables. Extraneous variable control is the regulation of extraneous variables. An extraneous variable is one that operates in the research situation in addition to the independent variable. Since it might affect the dependent variable, and since we are not immediately interested in ascertaining whether it does affect the dependent variable, it should be regulated so that it will not mask the possible effect of the independent variable. Preventing confounding variable. Failure in adequately controlling extraneous variables results into a confounding experiment, a disastrous consequence for the experimenter. That is, if an extraneous variable is allowed to operate systematically in an uncontrolled manner, it and the dependent variables are confounded. Consequently, the dependent variable is not free from irrelevant influences. In the illustration on citron, for example, suppose that those who received citron had been served a different breakfast than had the controlled participants. In this case, the magistrates will not know whether it was citron or something in the breakfast of the experimental group that was the antidote type of breakfast would thus have been an extraneous variable that was confounded with the independent variable. Confounding occurs when there is an extraneous variable that is systematically related to the independent variable, and it may act on the dependent variable. Hence, the extraneous variable may affect the dependent variable scores of the one group, but not the other. If confounding is present, then the reason that any change occurs in the dependent variable cannot be ascribed to the independent variable. If variation of the independent variable is systematically accompanied by variation of an extraneous variable, and if the dependent variable values for the groups differs, the reason for the difference may be because of the extraneous variable, not the independent variable. Control of the independent variable. I have said that control of the independent variable occurs when the researcher varies the independent variable in a known and specified manner. There are two ways in which an investigator may exercise control of the independent variable. 1. Purposive variation, that is manipulation of the variable. 2. Selection of the desired values of the variable from a number of values that already exist. When purposive manipulation is used, an experiment is being conducted, but selection is used in the method of systematic observation. If you are interested whether the intensity of a stimulus affects the rate of conditioning, you might vary intensity in two ways, high and low. Participants are randomly assigned into two groups and randomly determine which group will receive the low intensity stimulus, which one the high. In this case, you are purposely varying, that is manipulating or controlling the independent variable. This is an experiment. To illustrate control of the independent variable by selection of values as they already exist, the method of systematic observation, for example, consider the effect of intelligence on problem solving. By studying a widely differing values of intelligence, such as an average IQ of 135, a second of 100, and a third of 65, the investigator determines what values of the variables are to be studied. However, in this case, the investigator must find certain groups that have the desired values of intelligence. To do this, one might administer intelligence tests at 3 different institutions. First, One might study bright college students to obtain a group with an average of IQ of 135. Second, one might choose a rather non-selective group, such as high school students or army personnel, for an average value of 100. Third, one might find a special institution that will yield a group with an average IQ of 65. With these three groups constructed, a test of problem-solving ability will be administered and the appropriate conclusion reached. Observe that the values of the independent variables were selected from a large population. The IQs of the people tested determined who would be the participants. The researcher has not, as in the experimental example, determined which participants will receive which value of the independent variable. In selection, it is thus the other way around. The value of the independent variable determines which participants will be used. It is apparent that in independent variable control by selection of values as they already exist in participants. The participants are not randomly assigned to groups. This is a critical shortcoming of this method of systematic observation. Techniques of controlling extraneous variable. Although experimenters try to exercise adequate experimental control, sometimes a crucial uncontrolled extraneous variable is discovered only after the data are compiled. Errors of control may be found in the work of both young and experienced researchers. How can you control them? After an important extraneous variable is specified, how is it to be controlled? What techniques are available for regulating it so that the effects of the independent variable on the dependent variables can be clearly isolated? McGuigan 1997 illustrated the common techniques available for controlling extraneous variable as follows. 1. Elimination. This is simply by eliminating the extraneous variables from the experimental situation. For example, you can conduct your study in a soundproof laboratory to eliminate extraneous noises and lights. However, most extraneous variables cannot be eliminated. Other extraneous variables that one would have difficulties eliminating include age, gender, intelligence. Number 2. Constancy of conditions. Extraneous variables that cannot be eliminated might be held constant throughout the experiment. The same value of such a variable is thus present for all participants. One of the standard applications of the techniques of holding conditions constant is to conduct experimental sessions in the same room. Procedurally, all participants should go through the same steps in the same order. The techniques of constancy of conditions dictates that all participants use the same projector, recording apparatus, or other equipment, for example. Balancing. When it is not feasible to hold conditions constant, the experimenter may balance out the effect of extraneous variables. Balancing may be used in two situations. 1. When one is unable to identify the extraneous variables. And 2. When they can be identified and one takes special steps to control them. Examples of balancing techniques include balancing for unspecified extraneous variables, use of more than one control group to evaluate extraneous variable, balancing to control a known extraneous variable, balancing two extraneous variables simultaneously. 4. Counterbalancing. The general principle of this method is that in repeated treatment experiments, each condition in an experiment must be presented to each participant in an equal number of times. And each condition must occur in an equal number of times at each practice session. Furthermore, each condition must precede and follow all other conditions on an equal number of times. 5. Randomization. Randomization is a procedure that assumes that each number of a population or universe has an equal probability of being selected. If you select your participants in an unbiased manner from a population of 500 students, each of those students has an equal possibility of participating in your experiment. Randomization is used as a control technique because the experimenter takes certain steps to equalize effects of extraneous variables on the different group. Randomization has two general applications. Number one, where it is known that certain extraneous variables operate in the experimental situation, but it is not feasible to apply one of the preceding techniques of control. 2. Where you assume that some extraneous variable will operate but cannot specify them and therefore cannot apply the other techniques. If it is not reasonable to explicitly control an extraneous variable, it should be determined whether its potential effect may be randomly distributed over groups. If so, it will not differentially affect the groups. If not, perhaps the possible effectiveness of an extraneous variable may be assessed by using more than one control group. Study session summary. You learned that confounding occurs when an extraneous variable is systematically related to the independent variable, and it might differentially affect the dependent variable values of the two or more groups in the investigation. Purposive manipulation of an independent variable occurs when the investigator determines the values of the independent variable, creates those values, and determines which group will receive which value. Independent variable control through selection occurs when the investigator chooses participants who already possess the desired values of the independent variables. You also learned that all psychological research involves extraneous variables. These are variables other than the independent variable that may also affect the dependent variable. All potential extraneous variables involved in an experiment should be specified and classified according to whether or not they will be controlled. 4 techniques of control in addition to the use of randomization have been specified. With this, we come to the end of study session 6. Thanks for listening.